Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving absolute value function and some properties of periodic functions, right? So here we have to evaluate this integral that is from minus 10 pi to 20 pi, and the integrand is mod of sine x, right? So let us call this integral as I, right? Now here to evaluate this integral, what we'll do, we'll take the help of the concept of periodic functions, right? And we'll use one important property of definite integrals involving periodic functions, right? So let us first see uh, an integral of this type, that is suppose here we have p of t and here we have q of t, right? And here we have some function f of x which is periodic, right? So we are considering an integral in which the lower limit is pt and the upper limit is qt, right? And the integrand is a periodic function f of x whose period is t, right? So the period of f of x is t, right? And here p and q are integers, right? So z is the set of integers. So whenever we come across with this type of integral, then the value of this type of integral is given by q minus p, that is we'll take the difference of q and p which are integers, and then we multiply by 0 to t. Here we have t as the period of f of x, and here we have f of x dx, right? So this property shall be used to evaluate this integral, right? Now let us first compare this integral with this one, right? So if we compare, then we can easily find that p is minus 10, right? And q is 20, right? And here we have pi, here also we have pi, that is t is pi, right? And f of x is mod of sine x, right? And we know from trigonometry that the period of sine x is 2 pi, and the period of mod of sine x is pi, right? So here f of x is mod of sine x, which is a periodic function with period pi, right? So now we have obtained all the values of the variables here. So now this integral I can be written like this, that is q minus p, right? So q is 20, then minus, here p is minus 10, so here we have minus 10, and the integral from 0 to t, and t is pi, right? And f of x is mod of sine x, right? So now here we have minus minus plus, so 20 plus 10 is 30, and here we have 0 to pi and mod of sine x, right? So now our aim is to calculate the value of this integral, that is 0 to pi mod of sine x dx. Now to evaluate this integral, we'll take help of the sign convention in trigonometry, right? So this is the first quadrant, this is the second one, this is the third one, and this is the fourth one, right? Here we have 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and here we have 2 pi, right? Now see, here we have mod of sine x, right? So we'll consider only sine x function. So we know from trigonometry that the sine function is positive in the first quadrant as well as in the second quadrant, right? So when we go from 0 to pi, then the sine function remains positive, right? So mod of sine x can be directly written as simply sine x, that is plus sine x, when x belongs to the interval 0 to pi, right? So as long as x remains in the first and second quadrant, mod of sine x is positive sine x, or sine x is positive, right? So now this integral can simply be written as 30, and here we have simply 0 to pi, and mod of sine x can be written as positive sine x due to the definition of a mod function, right? Now we have a very simple integral here. So I is 30, and the integral of sine x is minus cosine x, right? And the limits goes from 0 to pi, right? Now we can take this negative sign outside. So we have minus 30. Here we have cos x, 0 to pi. And now we can substitute the limits and we'll take the difference. So we have cos of pi minus cos of 0, and this is minus 30, and this is cos pi is minus 1, cos 0 is 1, right? So I is minus 30, and here we have minus 2, so this is plus 60, right? So the value of this integral is equal to 60, right?